Hey again, welcome in the next video of Segmenting 101. In this video, we'll be talking about what is a join. What is a join? Well, people often talk about combining data extensions, joining DEs, maybe enriching data in a way. All of those can refer to somewhat the same concept. Specifically, the phrase join is used when people are writing SQL. If you haven't heard about that, it's a way of coding to query your database, to basically segment. If you haven't heard about that, don't worry. I'll be using the words combining and joining kind of interchangeably, again, approaching it from a conceptual angle, but just know that join also can refer to a specific type of code. Now, you can only combine data extensions when you have more than one DE, and that is why on my screen right now, I still have the same customers we've had before. Actually, in this case, I will not need cities. I'm going to remove that. So I have my customers table, and I'm going to add something new. I'm going to add orders, and we're just going to say we have a Mexican food app. We can just order Mexican food, home delivery, and we're going to have a list of orders that people made in the past. Now, let's take a few examples. So let's say there was a first order, and I will give that again an ID, a unique ID of 001. And then secondly, there would be an item like a burrito, and the burrito would have costed, I don't know, $20. It's probably an expensive burrito, but let's assume it's a burrito menu or something like that, whatever. And there might be another order, 002, and tacos for, I don't know, $10. Now here's the thing. This is nice, but how do we know to whom, who made that, who ordered that burrito, who ordered that taco? Well, as it turns out, the way databases are structured is usually for different concepts, for different topics, you would have a different data extension. So just like we have a separate DE for customers, we'd have a separate one for orders. But of course, an order is made by someone, and we would like to store that information because, as we'll see later, we might want to use it for segmentation. So almost always when you have these what we call related data extensions, related tables, there will be kind of a lookup, if you're familiar with that term. So for instance, in this case, orders will be related to a customer ID, something like this. So let's say that this burrito was ordered by John. Then his customer ID will be, then the customer ID for this burrito, for burrito 001, will be customer 001, and so on. I actually have already prepared a short list of data, and don't mind the rest, we'll get to that later. And boom. So here's a whole list of different orders people could have made in the past. So for instance, just test yourself real quick. So let's say orders 004 burrito. Who made that order? Who ordered this thing? Well, this is actually a trick question because we don't know. Here there's a customer ID 005 and it doesn't show up in our customer database. So maybe the customer got deleted. Maybe it was a duplicate before. In any case, this is an orphan kind of related record. But let's take an example that does have a customer. So take 006, order 006, nachos. Who do you think ordered it? 3, 2, 1. That's right, customer 002. Now, this little mental exercise we've been doing just to look up which order was made by which person, if you repeat it over, that's a join. So what I mean with that is, what if I want to have a list of not just customers and orders, but I want to have a list of all the customers with all their orders? This is exactly what combining a table would do for us. And so essentially what people would do is maybe we would create a new table, we'd call it customers with orders, and in SQL terms this would be a join. And if I want to be really specific for the people who are going to delve deeper later, there's an inner join. And what information do I want in my inner join? Well, it's actually kind of simple. We are going to, at least in my case, I want to have all the information from customers, ID, first name, email. I also want to have all the information from orders. Now, the orders table does contain a customer ID already, and I have already copied that from the customers table just now, so I can safely skip that column. But I'm going to take the other fields like this from orders. I'm just going to paste them next to it. Now here's the thing: customers has an ID, orders has an ID. Both fields are called literally ID. This can be confusing, so to make it a little bit more transparent, we're going to rename it to customer ID and order ID, making it nice and sweet. Okay, now what a join does is to relate records using a relevant ID that serves as a lookup. So if we're going to combine these two tables, we're basically going to use a customer ID to map the records from both tables to one another. And we're going to do this exercise now mentally. Again, this series is all about understand the concept. If you understand this concept, you will have learned a lot about how data is combined and how joins actually work. So let's start with customer 001, John. I'm going to start with his information. Now, what order ID, if we would go through the orders table one by one, what order ID would first follow? Think about it for a second. And you're right, it will be 0001. Because if you look at 0001, it has a customer ID of C001, which is John's record. Okay, so I'm going to copy paste this information. This would be the literal first join of a full joining operation. So, but let's keep going. Would there be another combination? Before we switch to Mary, actually, we have to double check if there's any other record that relates to John. And there actually is. Can you spot it? So, yes, there is a second match for John, and it's the nachos. It's order 005. You can see this too has 001, and we can copy paste that. And then by now you can probably see that also order 7 was made by John, again for the same reason. So I'm going to add that here as well. By the way, note that when I'm combining data extensions like this, John's information is getting duplicated, and that'll be interesting for one of our next videos. But for now, don't pay too much attention to that. And let's continue our join operation. So now we found all matches between customers and orders for John's information for C001. What about Mary, C002? Well, let's look in our other table, shall we? What order would you match to Mary? Take a second. So in this case, it's 0002 because 0002, the burrito here, has a lookup to Mary. So we can just copy paste Mary's information. We can also copy paste his burrito information. And then we can continue. For instance, Mary also has the next order 03. So I'm going to copy paste information as well. And so on and so on. So, I mean, now I've done this operation for John and Mary, and I think we've completed it. But let's see for Ken. Is there a join we can do? Well, it turns out there isn't. It turns out that in the order table, we don't have any reference to Ken. And so in this case, we wouldn't even create a record because there is no overlap, right? There is no overlap between the two tables. And that's what combining data extensions means. That's what a join means. So actually, we're not going to adopt Ken in our resulting table. There will be an exception here, by the way, for those who want to explore SQL further. If you do an outer join, actually Ken would be saved, or a left join. But in this case, we're doing an inner join, and he would not show up in the result. And then we also have Jess. And let's see real quick. Neither Jess has any lookup, so also Jess will not appear in a resulting data extension. And on the other hand, you might have noticed that there was the burrito with lookup to C005, and here it's the same thing. There's no C005 in the customers table, so for that record either, there's no match. So our resulting table is simply these overlaps. And that, in a nutshell, is a join. Oh, there is actually one more record that I almost failed to mention. That we have to join. So for Mary, there was one more lookup, namely 006 nachos. So now we can see all the orders with customer record 1 have been mapped. Those were all for John. All the order records with a lookup to Mary, C002, have been matched, and then this one doesn't have a match. So now we have actually joined all the records that we could join.